All right, we're going to talk about quadratics, starting with the standard form and graphing from standard form. So we're given a quadratic function, y equals 2x squared minus 8x plus 6, and the first thing we're going to want to do is to find the vertex. So to find the vertex, we take negative b, where negative 8 is our b value. So negative of negative 8 is positive 8. Over 2 times the a value, where the a value is the coefficient of x squared. So the vertex here has the x value of 2. Then to find the y value of the vertex, we are going to go ahead and actually plug in 2 into the equation. So I have 2 times 2 squared is 8, minus 8 times 2 is 16, plus 6. So I have 8 minus 16 is negative 8, plus 6 is negative 2. So I'm going to put the vertex right here, the point 2, negative 2. Then what I like to do is find, use x values on opposite sides of the vertex. So like I'm going to put in 1 and 3, and I'll put in 0 and 4. And this will help me plot some points. So I'll go ahead and plug those points in. If I plug in 0 up here, I have my y-intercept of 6. If I plug in 1, I get 2 minus 8 plus 6, which is 0. And then because of symmetry over the vertex, what I know is that if I move 1 to the left from the vertex, I'm going to have the same y value as if I move 1 to the right from the vertex. So this will be 0 as well, and you're welcome to plug it in to confirm. The same goes for 2 left from the vertex. I get out a y value of 6. So 2 right from the vertex, I'll also get a y value of 6. Now we talk about the domain and the range of our quadratic. Domain of every quadratic is all real numbers. The range will start at the vertex, and in this case go up because I have a positive leading coefficient. So I want to start at negative 2, and I want to go up to infinity. Now I'm going to go ahead and graph it. I know I have a vertex at 2, negative 2. I've got zeros at 1 and at 3. And I've got a y-intercept of 6 and another value at the point 4, 6. And then I can go ahead and, to the best of my ability, sketch my graph. Okay, and that is a y-intercept there. So then the questions are, do I have a max or a min? Well, I have a min on this graph because the graph opens up. The quadratic is in standard form, so my a value is 2, my b value is negative 8, and my c value is 6. So I have 2, negative 8, and 6. The a value in the problem is 2. What that does is creates a vertical stretch on the graph. Okay, so it's going to be stretched vertically from the original y equals x squared form. The axis of symmetry is always x equals and then the x value of the vertex, so x equals 2. The y-intercept is the point 0, 6. And we get the y-intercepts, or I'm sorry, the x-intercepts by setting f of x equal to 0 typically. We got lucky this time because when we plugged in the points 1 and 3, we got out the x-intercepts. So now we're going to graph one from factored form. When I have factored form, the first thing I do is I want to find my line of symmetry, which is going to be the average of the two x-intercepts. And so right away, I know I have x-intercepts where each factor equals 0. So x minus 2 equals 0, x plus 1 equals 0, which gives me the x-intercepts of 2 and negative 1. And I went ahead and put those in here. And I'll go ahead and graph them over here. The point 2 and the point negative 1 on the x-axis. Well, if I average those, 2 plus a negative 1 divided by 2, I get 1/2. So the equation of my line of symmetry is the vertical line x equals 1/2. And I can go ahead and graph that. And I'll put it in at 1/2, just about, to the best of my ability with my poor drawing skills. But here it comes in here, y equals 1/2. Now the vertex is actually, the x value is the x value of the line of symmetry. So in order to get the y value, I'm going to plug 1/2 into my original equation. So I have 1/2 minus 2 times 1/2 plus 1. 1/2 minus 2 is negative 3/2. 1/2 plus 1 is 3/2. And so I get negative 9/4. That is the y value of my vertex. To get the y-intercept, I'm going to plug in x equals 0 into the whole equation. So I get negative 2 times 1 equals negative 2. And to find out if I have a max or min, I look at my leading coefficient, the sign of it, and it is positive, so I have a min. So now I can go ahead and graph. I need a vertex at the point 1/2 negative 9/4, which is right down here. And then I have a y-intercept at the point 0, negative 2. So I can go ahead and sketch a graph of my quadratic. It's supposed to be curved there. It's not an absolute value, it's a quadratic. Okay, so now let's go on to the next skill. We're going to work to complete the square, which effectively says what we want to do is take a quadratic in standard form and put it in vertex form to make it easier to go ahead and graph it. So let me find a good color to use. I'll use green this time. What I'm trying to do, if I have a standard form, what I want to do is find this value c that makes x squared minus 3x plus c a perfect square trinomial that factors into a square of a binomial. So in order to find that c value, I take my b value, the coefficient of x, I divide it by 2 and I square it. Okay, so in this case, my a value is 1, my b value is negative 3, I've written those here, and my c value is going to be negative 3 over 2 and squared. Again, b over 2 squared, so that is 9/4. So if I say x squared minus 3x plus c equals x squared minus 3x plus 9/4, I now have a perfect square trinomial. And if I put it in factored form, I get x minus 3 over 2 all squared, which actually multiplies out to x squared minus 3x plus 9/4, and that is the square of a binomial. Okay, so what are we going to do with that? Well, let's do some practice first. Let's find the c value that makes this into a perfect square trinomial. So the first thing we do is we take our b value, in this case it's 6, divide it by 2, and we square it. So I have 6 over 2 is 3, and 3 squared is 9. So my perfect square trinomial is x squared plus 6x plus 9, and I can rewrite it as the square of a binomial to be x plus 3 all squared. Let's do the next one. Here, our b value is negative 12. Divide negative 12 by 2, square it, so I have negative 6 squared is 36. So x squared minus 12x plus 36, and then I have x minus 6 all squared as the square of my binomial. And then last, this one is the trickiest because it has this coefficient of 2 in front of x squared. And you can't complete the square with any coefficient other than 1, so we actually have to factor this out to get x squared plus 2x, excuse me, the 2 factors out as well. Sorry about that. So we have x squared plus x, and then when we factor out a 2 out of c, we get c over 2. Now we use this b value equal to 1. So our b value is 1, we divide it by 2 and square it, and we get that 1/4 needs to go in right here. So if I have, let me change color to make this clearer, if I have 2 times, and then here x squared plus x plus, and what I need here is 1/4, I will be able to rewrite this as 2 times x plus 1/2 all squared. And I will say that the c value, since c over 2 was equal to 1/4, if I cross multiply, I get that 4c equals 2, and then c equals actually 1/2. So it's this value was the c value in the end. All right, so what we want to do is change from standard form to vertex form to make this easier to graph. That's the goal here. So I gave us a kind of difficult one to work through in the notes. We're going to start by, we have to factor out this negative because we can't complete the square with a coefficient other than 1 in front of the x squared. So we have negative 2, we factor it out, we have x squared, and then we'll have minus 2x, and then this is the strange thing that makes this difficult. I'm going to go ahead and add in a blank here, And then I'm not factoring anything out of the 6. I'm just going to leave that 6 out by itself. This makes your life easier if you do it, so I recommend that you do it that way. So now we're going to solve for this value, which will be the value that completes the square for x squared minus 2x plus something. So the b value in front of the x is -2. Divide -2 by 2, square it. -2 over 2 is -1. -1 squared is 1. So what I've done here is I have input a 1 to complete the square. Do you notice, though, that it's actually -2 times 1? So I've really added -2 to this equation. To make the equation balance out, since I added -2 here, I have to add a +2 on the right-hand side. But this enables me to write the function in vertex form. So I have -2, then I have a perfect square trinomial. I have x squared minus 2x plus 1 factors into x minus 1 all squared. And then out here, I have 6 plus 2, which is a +8. Now, why did we do that? Well, the vertex form is now apparent because we have x minus 1, so the x value of the vertex is 1. We have a +8, so the y value of the vertex is 8. The equation of the line of symmetry is just x equal to 1 here. For the y-intercept, I like my standard form to give me the y-intercept, which is the point 0, 6. I'm going to skip my x-intercepts for a moment. I'm going to comment that I have a max here. I have a max because I have a negative leading coefficient, so this graph will be down. The domain of all quadratics is all reals, and the range, because we go down, we have our max value at 8, and then we go to -infinity. So we have -infinity to 8. So let's start graphing what we have. We have 1 and then 8 as our vertex. We have a y-intercept of 6, and I'm going to use symmetry to put a y-intercept there. And then what I really need now are my x-intercepts. And so in order to get x-intercepts from vertex form, what you're going to do is you are going to set the vertex form equal to 0, and you're going to solve. So what I'll do is I'll subtract 8 to start off with, and then I'm going to divide by 2. I'll bring it up over here. So I get 4 equals x minus 1 squared. Then I have to square root both sides, and I have to take the positive or negative square root of 4, which is plus or minus 2, which equals x minus 1, and then I need to add 1 to both sides. So 1 plus or minus 2 equals x. If I have 1 plus 2, that's the point 3, 0. And if I have 1 minus 2, that's the point -1, 0. So I'm going to come over here and put in an x-intercept at 3 and an x-intercept at -1. And then I can go ahead and sketch my graph of my quadratic from vertex form.